Hello class. In our yesterday's class, we have seen what is crystal lattice. Then we have seen unit cell. We discuss about characteristics of unit cell. Then we classify types of unit cell into primitive unit cell, centered unit cell, and in that we have classified it as face-centered cubic unit cell, body-centered cubic unit cell, which in short form is called BCC, and face-centered is known as FCC. And then we discuss about end-centered cubic unit cell. And then we discuss about what are Bravais lattices. And so we came to know that there are 14 Bravais lattices. And finally, we discuss about this table. In this table, we came to know that what are the total number of atoms per unit cell in each type of unit cell. Say for example, in primitive unit cell, the total number of atoms per unit cell is 1. In BCC, that is body-centered cubic unit cell, the total number of atoms is 2. In face-centered cubic unit cell, the total number of atoms is 4. Up to here we have discussed in our last class. Now today we'll discuss about closed packed structures. What does it mean? So the constituent particles are closely packed in solid and there is minimum space between particles. These structures are called close packed structures. So in case of solid, we know that the constituent particles are very tightly packed and the distance between the two particles is very small. So these structures are called as closed packed structures. Now we can classify this as in two types: close packing in one dimension, close packing in two dimension. So what will happen in close packing in one dimension? When the spheres representing particles are touching each other in a row, it is called close packing in one dimension. So if you keep the different particles in a row which are touching with each other, so we can call this as close packing in one dimension. Whereas close packing in two dimension means this type of packing is obtained by placing the rows of closed packed sphere. This can be done in two ways. So close packing in two dimension can be done in two ways. One is square close packing, another is hexagonal close packing. So in square close packing, what will happen? The particles in the adjacent row may show a horizontal as well as vertical alignment, forming squares. A central sphere is surrounded by 4 other spheres in two dimensions. So you can just see in the structure how a square close packing is formed in two dimensions. Next is hexagonal close packing. This is also a close packing in two dimensions. The second row particles may be placed above the first row. It is repeated in the next row. Each sphere is in contact with 6 other spheres. So you can see that the middle one is directly connect with the 6 other spheres. Because of that, it's hexagonal close packing of spheres in two dimensions. Okay, so first we discuss about close packing in one dimension, then we discuss about close packing in two dimension, and in that we have seen we have got two types. One is square close packing and we have got hexagonal close packing. Now let us see what is close packing in three dimensions. All these solids exist in three-dimensional structure. These structures can be obtained by placing two-dimensional layers one above the other. They can be of two types. One is square closed packed layers. Square closed packed layers. So in this arrangement, what will happen? Spheres of both the layers are perfectly aligned horizontally as well as vertically. The arrangement of spheres at the first layer is called A type. All the layers have same arrangement. Thus the lattice has AAA type pattern. Okay. So in the coordination number is 6 in 3 dimension. So here also in case of 3 dimension we have got two kind of packing. One is square closed packed layers and hexagonal closed packed layer. So in hexagonal closed packed layer, it is more efficient and leaves less space unoccupied by spheres. The central space is in contact with the 6 other spheres in 2 dimension. So This is the hexagonal closed packed layer. So today we basically discuss about close packing and its type. Okay, so today I'm not putting any assignment to you, but I suggest you to go through the notes that I have explained to you, and keep the things, important things in your mind.